Hello, my name is Keith Rucker. So, project for today. We're back to working on the Vance planer matcher. I've had another couple of weeks of break from working on that as we were working on the table saw restoration that we finished up a couple of weekends ago. But with that project behind me now, I really need to get back focused on finishing up this big planer project. It's been going on for almost 2 years now, and I'm getting pretty close to being done with it. I just need to concentrate on getting it finished up. So unless something comes up here at the museum that's kind of an emergency job that needs to be done, my hope is that over the next month or two that I'm going to be able to really focus on finishing this project up, because again, I'm anxious to get it done. I've been working on it for a very long time, and it's time to get that over so we can actually start working on some other projects that are coming in. I know of one little thing that I'm probably going to have to do. That'll probably be a full-day job coming up, just because of some time management things going on. But anyway, we're going to work on concentrating on this. So a little bit of background on this. So probably it's been, probably a year and a half, maybe about a year and a half ago, I actually started the process of making this piece. So what this is the outfeed pressure plate on the Vance matcher. So as it goes through, it will plane the top of the board, it will plane the two sides of the board, and then there's the last cutter head is planing the bottom of the board. And what this does is this is just a pressure plate on top of that holds the board down, because the planer head is up underneath this piece hitting, and it just needs some pressure to hold it down. So it's just a flat piece. You can adjust it up and down on the machine depending on the thickness of the board that is going through. But when we got the machine, this piece was gone. It was missing in action. Don't know what happened to it, but when we received the machine was missing this piece and some other pieces related to this. So I did some research. I actually found a person that had the same model, or a very similar model anyway, made by Vance. So it was, I think, just a little bit later than the one we have, but according to the catalog pictures, this piece was the same on it. So he was kind enough to go out and take some measurements of it, take a bunch of pictures of this piece, send it to me. I was able to make some drawings. We went back and forth, confirmed everything was right. And then what I did was actually made this wooden pattern here to send to a foundry to have the new piece cast. So this is standard practice. You know, back when they were making this machine, every cast iron part on there would have had a pattern that would have been used in the foundry to make that piece. And basically what I did was I recreated that pattern, or as close to it as I possibly could based on the information that I have. So this pattern here, again, is made out of wood. It's a split pattern, so it breaks into two pieces. And the reason is that you would mold half of this in the sand, flip the whole mold over, you'd put the other piece on here, and then you would mold the top half and the top piece of the flask. You then separate them out, pull the wood parts out of the mold, which would leave that cavity, put the mold back together, and you would fill it with cast iron. And that's basically the process of sand casting. So this pattern, again, you know, I just made it. It's just made out of wood. It was made for just one-time use. You know, we only needed one part made. So, you know, if in a commercial pattern, you probably would have gone to some extra lengths to make it where you could reuse it over and over and over again. This one was just one-time use, so it's good enough. It did a good job, and as you can see, the end result. We sent this off to Cattail Foundry, which is an Amish foundry up in Ohio, I think. I always get the state wrong. I'll have to look it up and put it on the screen. But anyway, I sent this up to them. I've used Cattail Foundry a lot. They are a small, again, Amish foundry that specializes in these little one-off parts for people that do restoration work like me. So mostly they kind of cater to the steam and gas engine people out there. A lot of the Amish people use a lot of the old steam engines and stuff. And in that steam and gas community, they're very well known. And anyway, I sent the patterns up to them. A couple of weeks later, they sent me back this casting, along with several other castings that I had done at the time. So what I've got to start with here is just a raw casting. This is, again, cast iron. It was made from that pattern over there. Of course, it's pretty heavy, pretty big piece. And the task for today is we're going to start working on machining this out to the final usable part. So what do we need to do to this casting? So the first thing that we'll work on is actually the bottom. So again, the bottom here is all just rough. And first thing I'm going to do is come in here on each side. These ends are a piece that will just slide up and down in a set of a slot on the stanchions on the machine. And I've got to machine these eventually to the right width, but first we're going to work on the bottom, and I got to just kind of put some relief on either side of these. Then we're going to machine this bottom flat, and once we get that bottom machined flat, then we'll set it up, and that will become our reference plane that we'll work off of. And then we'll machine the sides of these on both sides to the correct width, and of course square to the table or square to the bottom, so that as this goes up and down, you'll have a nice flat piece that's square to the bottom. Also going to have to drill and tap 2 holes in here for the elevation screws, and that will probably be the last step we do. So we're going to get started. Most of this work, or at least a lot of this work, we're going to actually be doing on the horizontal milling machine, just to because it's going to be a little bit easier to do that. So we'll lay this piece down on its side and then put a shell mill in here and do most of the bottom work, and then we can flip it up and again have a shell mill on the side or some type of cutter on the side, and that will allow us to do these pieces going up and down. So again, another good use of the horizontal mill versus a vertical mill when you need to do machining that is horizontal to the plane you're working in rather than vertical. If we were having to do this on the vertical mill, to get this piece flat on the bottom, we'd have to flip this piece upside down and figure out a way to clamp that down. It's not very stable, but this way we can just lay it down flat here on its side, get it clamped down, and work off the back here. It's going to be much easier to do this on the horizontal mill. So anyway, let's get started. So let's talk a little bit about what we got to do here and some of the challenges that we're going to have working on this particular piece. So number one, let's just look at here. The width, the entire width of this is about 29 inches, a little over 29 inches. The piece on the bottom here is just a little over 24 inches. So we've got to basically work on this entire bottom surface here using a face cutter shell mill that's going to go in up here. And my shell mill is well, let's just say I got a couple shell mills anywhere from about 4 to 6 inches in diameter. So think of it, let's just say 4 inches, so you got 2 inches on either side, so you kind of lose 2 inches off of the travel that you're working with in order to get a full cut. And looking at my machine here, I've got 27 inches of usable travel in here. Again, my part is 29 inches, 24 inches, and let's just say we're going to use a 4-inch shell cutter. You're going to lose a total of 4 inches out of that. We got 27, so I'm already don't have enough travel capacity in this milling machine to do this. So what do? You could go out and buy a bigger milling machine that has a bigger table with a bigger, wider travel. Quite honestly, I would love to have a larger horizontal mill than this. I do a lot of big work. This Kearney Trecker number 2H mill, I love it. It's a great mill, but again, I wish I had one that was a little bit bigger, but I don't. I'm stuck with what I have. I could send this out to another shop and have them do the work, but out here at the museum where I volunteer, we're basically doing this on zero budget. There's no money to go spend to have this done. So again, we got to figure out a way to do this using the tools and equipment that I have available to me in this shop. So I've done a lot of thinking about it, actually over the last couple of weeks. I knew this problem was going to come up, and we're going to try something here, and I think it'll work, but I want to tell you about it. So again, before I say that, one of the things that a successful machinist has got to learn how to do is learn how to get the job done with the tools and machines that he has available to him. In a lot of cases, that may not be the best way to do it. And I get a lot of people on my comments like, well, why didn't you do it this way? Or why didn't you do it that way? Or, this is a better way of doing it. And in most cases, they're right. it is a better way of doing it. But if I don't have access to that equipment, it's not really an option for me. So here's my solution that I'm going to do this with. What I'm going to do is I'm going to put a plate up underneath this, and in the bottom of that plate I'm going to put in a key that fits into this slot. And what that will allow me to do is I'm going to actually attach this or bolt this down to that plate, and what that'll allow me to do is be able to slide this piece back and forth and be able to keep it very close to being in track with the cutter, so that I can come in here, I'll face off about half of it, I'll stop the machine, I'll move my table, I'll then slide the part again on that plate and in these ways in my table, and then I will finish the cut. Is that the perfect way of doing it? Absolutely not. You know, I'm probably going to have a couple of thousandths of an inch on the bottom here where things don't line up just right. But quite honestly, for the part that I'm working on, I mean, this is just a pressure plate to hold a piece of lumber coming out of a planer, and you know, the tolerances that I'm dealing with, you know, it doesn't have to be just perfectly dead on. There's some room for some error. Several thousandths of an inch is not going to make a difference. So that's my game plan. That's how we're going to move forward. So next, what we're going to work on is getting that plate ready to go on here, so that we can then bolt this down to that plate and be able to slide that plate back and forth to do these cuts. All right, give you guys an update here of what we do. I've been working on making the sled that we're going to clamp this piece of work down to. And let me show you what I did here. So this is just a 4-inch piece of steel, 4 inches wide. I don't know, what's that? Maybe 3/16 thick, 1/4 inch thick, something like that. Just something I found laying on the scrap pile. I then took a piece of 3/4 inch square stock. I had to mill a little bit off to make it fit this slot, but I got it fitting that slot just as tight as I could get it and still be able to slide back and forth. And I then went in, I just drilled and tapped a couple holes in here. I drilled and countersunk the holes here so that this would attach this slot down here on the bottom. And now that fits down into the ways on this, or the slots on this table, and it gives me a sled that I can move back and forth. Again, the plan is we'll clamp the piece to this, and then we'll clamp everything down to the table, so I can start on one end, mill about half of it or a little bit more, reposition my table, reposition the work, clamp it all down, and go again. So again, this is my solution to the problem that I had. In an ideal world, yes, I would use a bigger machine where I could do it all in one pass. I don't have that available, so I'm using the resources that I have available to me to get the job done. This is my approach. I'm sure some of you will have some other ideas, and I welcome your ideas. But again, you know, if you come to me and say, well, you should have just used a different machine, that's not an option for me. And I think this is going to work fine. We'll see what the end results look like. I'm confident we'll be okay. So the sled is pretty much complete now. So after we put the piece in the bottom, the little key in the bottom, I went and just welded some 1/2-inch nuts on here to give me something to attach my studs to here. I got a bolt back here that I can raise and lower a little bit. That just gives me a prop in the back. And now I've got this piece clamped to this sled. And as you can see, now I can slide the whole sled on the table of the milling machine here back and forth. And with that, I have an extended range of travel that I can actually work on machining this larger than my table. So again, yeah, you know, there's a little bit of play in there, but it's, you know, it's not much. When you the side to side, I mean, I'd have to put an indicator on it to look at it, but it feels like it's no more than maybe 10 or 15 thousandths of an inch. And based on my T-slot that I put in the bottom there, or not T-slot, but the piece that goes into my slot here, that's about what I would expect. But for the job that I'm doing, that's plenty within tolerance. So I'm happy with this. I think this is going to work. So what we'll do is we will now just come in here and clamp the whole fixture down to the table. put our cutter in here, and we'll start milling this out. All right, we have everything set up here. The piece is clamped down on the table. I've got everything lined up here. What I'm going to do is just touched off right now on the bottom face down here. And what we want to do now is we want to feed this in. On these ends down here, this is just where the riser goes up and down. I actually want it to be recessed in on the bottom. I don't want it to be flush with the rest of the piece. So we're going to cut that in about 150 thousandths of an inch, and I'll just use my dial over here, or actually I think I'm going to grab an indicator and put on here and feed that in. All right, feeds and speeds, everybody always asks about that. So I have my cutter RPM set on 322 RPMs. This is a shell mill here with, let's see, our 1, 2, 3, 4, 5, 6 cutters, 6 teeth, or not a shell mill, but a face mill, carbide tip face mill. There's 6 teeth, so we're making quite a few cuts per minute here. And I have my feed going at 5/8 of an inch per minute, and we're just going to feed up. All right, we have this side notched now. The next step here I want to do is we want to actually slide it over, use the sled feature here, and take it over to the other end. We're going to notch this in, and then we'll start facing from the other side. Because of the way the setup is, I'm actually doing some climb milling over here, which is sturdy as this setup is. It's not really an issue, but I would rather my cutting angle be going down on the table rather than up from the table for the main mill job here. So we're going to basically pull the table out. I've got an indicator. We'll slide everything down as far as we can go. We'll crank the table down, go in there, start from the other side, and get this end done. So I'm going to go ahead and pull these clamps up. Again, these clamps, all they're doing is just holding everything down to the table. That's not affecting the sled itself. This is clamping the sled and the piece, everything at one time. So now let me pull my table out here so I have clearance with the cutter. 100, 200, 300, that should be plenty. Okay, and we'll just slide this down. That's probably good. And come back in about right in there, and we'll reclamp everything down. And I'm going to take this back in 100, 200, 300 thousandths right there. That should be the same depth as the other side. That should be pretty close to that edge. Not critical, that's perfect. All right, so we're ready to take this side down over here. We're cutting. I did change my feed rate to 1 inch per minute, and that seems to be giving a real nice finish. All right, we have our 2 steps now milled in the ends. We're ready to cut the face across the front here. So first thing I'm going to do is we're going to lower this down where the center of the piece is about in the center of the cutter head. And I'm just going off of my parting line here and lining it up with the center. It doesn't have to be perfect, just to get it where it's roughly in the center. Now, next thing I want to do is I want to pull my cutter out to hopefully get a good clean face across here. And so right now I'm going to pull this out about 175 thousandths from where we were at. That should leave me about a 75 thousandths cut. And we'll start seeing how it looks like if we need to. If it doesn't look like it's taking much off the front, we'll come back out and readjust that here in just a minute. But I think that's going to be a good starting point, and we're ready to go. Let's get our cutter going. So now, instead of going up and down, I'm going to lock my up and down, and we're going to unlock the table there, and we're just going to feed it in this direction, and we're going. All right, I can already tell that we're not quite cleaning that face up, so let's pull this out a little bit, and we're going to go in about another 50 thousandths. And we'll see what that looks like. All right, we're going to stop right here. I'm almost at the end of my travel. So I'm going to pull the table out using the dial indicator here about 200 thousandths. That should give me plenty of clearance back here on the back side. It does. And we will move our table down. And we're going to shift it all again. All right, let's move this down here back about to where we were at. Be about right there. And let's now feed our table back into 0, and it should start cutting again right on 0. That's 100 thousandths. All right there. I was a little too far. I didn't think that was right. All right, should go another 100 thousandths now. All right, we're about 10 thousandths. All right, so we're about 6 thousandths out where we're touching off there. I'm going to stop there because obviously it's just barely touching the face, which tells me I probably had about 6 thousandths play in the sled, but that's fine. Again, well within the tolerance that I'm working in. And let's get our feed going here again. Alright, I think we got it all faced off. Let's pull it out of there and see what she looks like. Alright, there we go. We got a good flat surface, I think. Looks like we may have had just a little bit of skipping right there in the middle, but nothing major. One thing that does jump out at me is I got a little spot right here. You know, I stopped 6,000 short according to my indicator because it sounded like it was touching off. But looking at the piece here, looks like I could have probably gone that last 6,000. So it's just a little bit of a rise there. I'm not too worried about that though, because I think what I'm going to do is just take this whole piece and we'll lap it on the bottom, and I should be able to take that out pretty easy. It's not much of a rise at all. I think that'll come out pretty quick. So it's a little bit warm right now. It's not what I'd call hot. I can hold my hand on it. But I'm going to let this cool down, and we'll see if we can work on getting that little bit out right there. So I've moved from the museum back out to my home shop. I had some stuff to do here at the house this afternoon. Couldn't stay out there very late. Plus, for the lapping job that I'm about to do here, I have this real nice flat joiner, my 16-inch crescent joiner, that I could work off of. And actually out of the museum they don't have a really good flat surface big enough to do this job. And as a bonus, I've got a little window unit air conditioner in my shop here at the house, and it's about 97 degrees and high humidity today, so this feels a little bit nicer to come over here and at least be a little cooler in the shop at the house. So let me tell you what we've done. I've got some 80 grit sandpaper. I'm going to start out kind of coarse with this. And I have taken some this 3M Super 77 spray adhesive. I just spray the back of the sandpaper with this adhesive and then just glue the sandpaper down. It'll come right up. You can take some acetone or something and clean it up, no problem at all. So I do this a lot of times when I'm lapping, and when you're lapping, the secret is having a good flat surface to work off of. And in this case, I got a pretty good real estate right here for this rather large piece. So here's the part again, and you can see it may be a little bit better here in this light, but as you can see where we moved it, there's just a little bit of a ridge in here, and I didn't try to measure it, but based on the dial indicator I was about 6,000ths out, and that's about what it feels like. So you know, I've got a little bit higher here than here. Quite honestly, I'm not that worried about it because, again, knowing what this is, it's just a pressure plate to hold a piece of wood down as it's being planed up underneath it. It needs to be flat, but, you know, if it's off by even 20,000ths from one end to the other, it's not that big of a deal. It's not going to be that big of a deal at all. So I'm still within tolerance here, but I do want to try to smooth this out and take some of that out. So the lapping table is a good place to do that. So we've just created a makeshift lapping table here, and I'm going to just put this down. This is probably going to take a little bit of elbow grease, a little bit of sweat to get this done, just because this is a pretty massive piece of steel, but we're just going to rock it back and forth. Don't have to push down on this one. The weight of the job is going to do it itself, weight of the part. Quick update here. I've been lapping this now. I actually started last night. I did a little bit more this morning. My sandpaper has pretty much got worn out, and I don't have any more of this grit, so I've got to get some more sandpaper really to finish this up. It's coming along pretty well though. I mean, we've got this whole back part here is hitting up into about right in here, and it's starting to drop down a little bit, and then there's a void right here. We're actually hitting some in the middle here. There's a little bit of voids on both sides, and right here there's still just a little bit of a lip. All right, we have a little bit of a funky setup here to make all this work out. So the goal here is we're trying to narrow these pieces down here to the size that it's going to fit in there to slide up and down in the groove on those upright stanchions that we milled out earlier in another video. So I've got a small face mill on here, a little bit smaller diameter. I'm going to have to make 2 passes to get this, but I really need for the entire diameter of the cutter to go past this face to get a good clean face. So I had to go with a smaller one, and I also had to raise this whole thing up a little bit high on the table by putting some blocks under it to give it enough travel for the cutter to go completely down, just because I'm limited on how high the table on this milling machine will rise up. So anyway, we've got it again bolted down to the sled so we can do one side to the other. That's these pieces here, and then additionally I have it clamped straight down to the table with these 4 clamps, and I think we're ready to go here. So what we're going to do is I've already touched off here. I got a 0. We're going to feed this in 250 thousandths. We'll do a face cut going down, or excuse me, we'll raise the table up. I want the force of the cutter pushing down on this part as we're cutting it. So that's the reason for that. But we'll go ahead and do that, and then we'll do the other side, and then we're going to have to flip it around and mill the back side of this. So let's get going. 100 thousandths, 200, and 50 right there. And let's feed our table down, or up, excuse me. So let's give an update of where we are on this project now. So last weekend, you saw where I left off in the video. We had basically gotten one side of this trued up. So this past week, I've been real busy, been on the road a lot, but I did have one evening that it worked out. I had a couple hours to run up here to the museum. And so that evening, I actually went ahead and cleaned up the back side of this as well as the ends, kind of got it to the right length. So these are now milled down to size. And I didn't have my camera with me. Sorry, guys. I left it at home, or it was at home. I wasn't planning on having time to come out to the museum and work, but it did, and it was going to cost me about almost an hour to run back to the house, get the camera, and come back out. So I just finished it up. But it was pretty much what you had already seen, but enough on that. So this is now all machined. It will slide down in here. In fact, this is heavy, but you can see now that it fits down in here. It slides up and down in those ways, which is exactly what we want. So the bottom is flat, or we still have a little bit of lapping to do, but it's more or less flat. These now fit in here. This part is getting close to being done. The next thing we need to do is drill and tap the holes in the ends here that we can put the height adjustment rods on to raise and lower it. So just like on the feed rollers, it's a very similar setup, and I'll move that so you can see it, but there's a crank up here on the top here that goes in the feed rollers that go in here, and when you turn this, that just adjusts this feed roller up and down. Same thing's going to happen on this pressure plate. We've got a piece that fits across here. We'll have to make the height adjustment screws that go in here, and that will raise and lower this. So now what we're going to do is come over and we'll go ahead and drill these out to the right size. These are going to be tapped for 3/4 8 threads. I'm not going to tap it the whole length though. I think I'm only going to actually have the threaded part in about the top inch and a half of this. That'll be plenty of metal. So we'll drill a hole all the way through. Then we'll counter bore out a larger hole on the bottom for just some clearance for that rod to go in there, and then it'll be threaded for probably about an inch at the top here for the rod to engage in there. So I've already made some measurements of where I want this. I took my blue Sharpie, put on here, and I actually got it marked on each side about the center of this boss, and we'll go ahead, get this set up on the milling machine, drill that out and get it tapped. So we got this ready to drill now. We're going to need to go up to 21/32 to get the proper size for the 3/4 8 tap left-hand thread that we'll be tapping this with. So I've got this set up on the mill here where it's parallel here. I use my center marks here, and I just lined up with the eye. It doesn't have to be super precision. I just need to get it pretty close to the center there. I scribed on there, so I just used my little center finder here, came down and found that point, and then checked it over here to get it parallel. So we're set up there. I'm going to start with just a center drill, then we'll get the hole started with a 3/8 drill, and then go up to that 21/32. Alright, just a comment or two here about working with cast iron. So you saw, unlike steel, you don't get that big stringy chip. You get more of this flaking, and as you can even see, some of this is almost a powder coming out there. And that's very typical for cast iron. It's just the way the material is. One thing to be cautious about though when working with cast iron is that this shaving that you get off of here, or this chip, or whatever you want to call it, this dust, can be very abrasive on your machine. So this is a metal dust, and it can get down into your ways, and if it gets worked in there, it just basically turns into a grit that can grind for all intent purposes those ways and put wear into it. So anytime I work with cast iron, I always try to do a real good job of cleaning it up afterwards and getting it off the machine. And to do that, I like to use a shop vac rather than air, because if you just blow it with an air compressor, a lot of times you're just blowing that dust and chips back into your machine. So I'm going to get my shop vac here. We'll get this cleaned up as good as we could. Also, I get a lot of questions on my comments about using a lubricant on cast iron. You can, but it's not as critical as steel. Cast iron, the way it machines, usually I don't use any lubricant at all. And again, the problem with using a lubricant is that oil gets in this dust, and it just makes it harder to get cleaned up. I like to work with it dry because I like to clean it up dry. And again, with cast iron, that works pretty good. You really don't need a good lubricant for it. So let's get this mess cleaned up. Alright, now what we're going to do is just counterbore the back side of this. Again, I just want about an inch up here at the top threaded, and I want the rest of this to have clearance for that 3/4 inch shaft to go through. So this is a 7/8 inch drill bit, which would just give me clearance for that elevation screw to pass through. And I just flip the part over. I'm not going to worry about clamping it down. It can center itself up on that hole. It doesn't. It just needs to follow that hole down. I did put a little block back here in the back, just to give something for this to go up against, because it's going to be turning in this direction, and the torque will need something to hold it on the table down here on this backside. So this is just a stop, and with that, we'll punch this on through. I need to go the entire depth of this drill bit, and that should give me about 1 inch on the bottom. It's not a critical measurement, but that should give me enough clearance to do what I want to do. And it'll probably be a little shaky to get started, but once that hole gets going, there we go, we're good to go. That's it. All right, we're down to tapping now. So I've got everything lined up here. Again, this is a left-handed tap, so I gotta get in my mind to go backwards on this. I am going to use a little bit of tap magic here on this. Just it'll make this tapping job a little bit easier. We're not making a lot of chips with this, and it's a pretty coarse, heavy cut, so I think that'll give us enough lubrication to kind of help us through that. Again, I've got a stop set up back here to help with the torque as this is going around, but I flopped it to the other side again because this is left-handed rather than right-handed. And I've got a little tap follower in here. This is a little spring-loaded center, basically, that will just help keep it aligned, particularly to get it started. So I think we're ready to go. We'll just go ahead, and again, this is backwards and normal. We're going left hand. All right, we're through there now. All right, so that's going to be a wrap on this upward pressure plate here for the Vance Matcher planer machine. So we went from basically a raw casting. We created a pattern, we sent it to a foundry, got the raw casting back. We machined the bottom of this piece flat. We then machined the sides parallel to the flat, so we had the reference surface to work off of to the proper thickness to fit into the slots on the uprights on them stanchions on the machine. Also cut these to length again to fit, so machine the ends off, drilled, counterbored, and tapped these holes for the elevation screws, and that pretty much wraps this piece up. So next step will be to make the elevation screws themselves, which again will be 3/4 inch 8 left-hand threads. I've actually shot a video on making some of those for the feed rollers, but I'm gonna probably go ahead and do another video on this because we're gonna be got a little different twist on that part of it, and I will cover that in the upcoming video, even though it is somewhat of a repeat. I'm gonna go ahead and put some paint on this, and it'll be ready to go back on the machine. Maybe this weekend we'll go ahead and get the elevation screws finished up. I'm not sure if I'll have time to get that completely done this weekend, or whether we'll have to finish that up next weekend. I've got limited amount of shop time this weekend with some family stuff going on over the weekend, so hopefully we'll have enough time to get all that done. So we'll have this in one video and the elevation screws hopefully in the other. I do want to make a couple of comments for you guys, my subscribers out there primarily, the guys that watch me all the time. Number one, we're about to hit that 10,000 mark. And as you guys know, if you watch my channel a lot, that's kind of been a goal of mine for a while, to get 10,000 subscribers to my channel. And when I looked this morning, we're only a couple of hundred away. So probably by the end of this coming week, I will have hit that goal, which is a big milestone. We're also very close to having 1 million views on my channel over about the past 10 months or so since I started doing these videos. So that's another little personal milestone that I'm looking forward to hitting, and probably hit that within about a month or so, getting to 10,000 subscribers. So to my subscribers, thank you for subscribing. Thank you for watching what I do, coming back week after week or whenever I can get videos posted up, and keeping track of it. I hope you enjoy it. I hope you're getting a lot out of it. If you're not a subscriber to my channel and you like what I saw, please hit that subscribe button. and help me hit my goal, and we'll continue adding new content to the channel, and hopefully you guys can see what we do out here at the Georgia Museum of Agriculture in this shop. Again, I'm a volunteer out here. This is not a full-time job for me. I have another job totally outside of this field, but this is what I truly love doing. And I spent some time in a machine shop back in the 80s before I went to college, so I learned a lot of those skills early on, and I enjoyed them so much that I've kept on doing it more as a hobby in later years, but it's still just an invaluable skill that I picked up serving an apprenticeship in the machine shop, and I'm enjoying sharing what little bit I know with you guys so that maybe you can be a better machinist as well. So just a couple of quick notes too. This coming week and the week following, I'm going to be traveling on the road with my job a good bit, so I'm not going to have a lot of time to shoot video. There's probably not going to be a lot of content added over the next couple of weeks. We'll get this video, maybe another one on the elevation screws. This coming week I'll be in North Alabama with my job for 3 or 4 days. Then the 4th of July weekend I'll be around home. May slip out to the shop next weekend over the 4th. But we got some family stuff going on that weekend as well. And then the following week, the week after the 4th of July, I'm going to be out in San Antonio, Texas at a conference. Looking forward to that, out right there at the Alamo in San Antonio. So I'll be actually on the road for 7 full days for that trip. So point being, I'm not going to have a lot of stuff posted over the next few weeks. Bear with me. We'll be back in the shop soon and making more videos. So again, thank you to my subscribers. Thank you for watching the videos, and thank you for commenting. Again, if you haven't heard me say it before, I read every comment you guys send in. I don't respond to everyone, I just don't have time to. If you do ask me a specific question, I will try my best to answer you. But I just don't have time to respond to everyone. But I do promise I'll read everyone, and I really, really, really appreciate your comments. So thank you so much for sending those along. So this is a wrap. We're going to call it quits for this part of the project, and maybe try to get started on those elevation screws here pretty quick. Thank you.